The question we are solving now belongs to test series 1. It is of network theory subject. In specific, it belongs to DC network solution methodology. As per this question, there is a variable resistor V which is connected in parallel with a current source of current I, and the whole VI characteristic of the variable resistor are as shown. The characteristic intersects with y-axis at -2 ampere and it intercepts with v-axis at -30 volts. We need to find the maximum power dissipated in the variable resistor PV. In the variable resistor V. We need to find the maximum power that gets dissipated in the variable resistor V. We know the power that gets dissipated in the variable resistor V can be written as I multiplied by the voltage, that is I is the current through the variable resistor and V is the voltage across the variable resistor. From the VI characteristics of the variable resistor, we see that the VI characteristic is a joining point of 0, -2 and -30, 0. 0, -2 corresponds to this point and -30, 0 corresponds to this point. So from this we see that the slope of the line is m is equal to -1/15 and the y-intercept is -2. From this we see that the VI relation can be written as I is equal to -v/15 -2. From this the power dissipated in the variable resistor can be written as P is equal to V multiplied by -v/15 -2. This can further be simplified as -v square by 15 minus 2v. So this corresponds to the equation for the power dissipated in the variable resistor at any voltage. We know that the maximum power is dissipated in the variable resistor when dP by dV is equal to 0. That implies -2v by 15 minus 2 should be equal to 0. So that implies V is equal to -15 volts. That is, the maximum power or the minimum power is dissipated in the variable resistor when V is equal to -15 volts. So to check if this is the maximum power dissipated, we need to find the sign of d square P by dV square at V equal to -15 volts, which comes to be -2/15. As this is less than 0, that is, as the sign of d square P by dV square is negative, we see that the value of V is equal to -15 volts corresponds to the maximum power dissipation in the variable resistor. From this we see that the maximum power dissipated in the variable resistor can be written as Pmax is equal to -15 whole square divided by 15 -2 multiplied by -15, that is equal to 15 plus 30, that is equal to 45 watts. From this we can see that the maximum power dissipated in the variable resistor is equal to 45, this is equal to the Pmax we can be written as minus of -15 whole square divided by 15 minus 2 multiplied by -15, which upon simplification becomes -15 plus 30 that is equal to 15 watts. From this we see that the maximum power dissipated in the variable resistor can be written as 15 watts. So the correct option is C.